Hi guys, welcome to the clash detection part. And as I told you before, clash detection is one of the most important and most crucial parts of Navis. In other words, Navis is created for the clash detection. Here, as you can see, I have prepared an RVT file and I'm gonna explain the topics on this file, and then for reviewing the topic we will consider all of the topics again in an actual project so that you can get familiar with everything, such as the issues and topics which may occur in the actual and big projects that you want to carry it out. Well done. Here, as you can see in this RVT file, I got two model geometries, I got two buildings, the original one and the copy one. Following that, I'm gonna make some changes on each of these models. After that, I'm gonna transfer these files to Navis and then check them out. Anyway, look at here. Here we got the beams, we got the long beam and their intersection with the channels and the pipes which is passing through the wall from middle of the wall. And let me open the view of level 1, and here, as you can see, the walls, I have overlapped some parts of the wall and there is no intersection between walls and columns. And if we check the ceiling here, the position of the columns are voided. Following that, we got some lights, but at the another model I want to make a copy from the selected wall by this way, then I paste it aligned to the same place. Note that when you copy a wall or an object and then paste it aligned to itself, the doors and the windows will be pasted aligned to the same place. Here, as you can see, I got two windows. So practically here we got two walls which are overlapping each other. But in the another model geometry, let me open the plan view. Here we got two types of wall, that one of them is thicker than the other, and the thinner one is located inside the thicker wall, which is not correct, it's repetition. And at the other side, as you can see, we got a wall here as I'm showing, and at the other side I have added another wall, and this is not correct too. So I have prepared an intersection in the thickness of the wall intentionally. And what else? For example, at the another model, I want to make some copies from the beams. So first of all, I select them by this way. Check this out. And I also select the ducts. I select them, then I open filter, I uncheck all of them, then I check ducts and structural framing girder, then copy and align to same place. Following that, I'm gonna show you how to find the clashes and the intersections and duplicates in Navis. For example, here we got a duplicated wall and also duplicated beams and ducts. Then at the other geometry we got no duplicates. For example, here one of the walls is placed inside the other one, and here there is an intersection in the thickness of the wall, and at the other side there are some longitudinal intersections. There are some parts which have longitudinal intersections. Here at the beginning of the video, I'm gonna explain the type of the clashes. We will talk about the clash detection later. Here we're just gonna talk about the clashes that can occur in the construction process. At first we should get familiar with the clash detection system of Navis, and then we will move on and go through clash detection topics, and I will explain everything. Very well. Here, as you can see, we got an RVT file here and we want to export it to Navis. As I have mentioned before many times, that you can export your Revit file directly to Navis and then open it there, and its advantage is that if you make any changes in Navis, then your RVT file or Revit file would be updated too. Or you can export your RVT file as a NWC file, as you can see, to save the scene as a NWC file and then import it to Navis, so that there is no direct connection between your RVT file, Revit, and Navis. If you make any changes in your file in Navis, Revit is not going to be updated directly, because you should export your file to Revit again and then update it there. So we're gonna have several transformation between Revit to Navis. Firstly, we export them to Navis for the clash detection, and then we should import it to Revit for the revising the conflicts. So at first we need to link Revit and Navis to each other, but as I told you before, we may not be able to link Navis and Revit in the big projects. So we have to save our file in NWC file in Revit. Revit. So no matter if you couldn't link your Navis and Revit to each other, because you can save your file as NWC and RVT to transform your file between Revit and Navis. So let me open the RVT file, but before that let me save my Revit file. I forgot to save it. I name it as Clash just for practicing. Then I open the file in Navis. I select and then click on open by this way. So wait for a second, and as I told you before, at this part we're gonna talk about the types of clashes in Navis, or the kinds of clash detections which we got in Navis. But I will tell you the points and techniques later, because we're not going through details. Wait for a second please. To open the Revit file. Well done, the Revit file is prepared. For example, check this out. Here if I select this wall, as you can see here the conflict or clash is clear. If I select the duct, if I select them or hide them, as you can see we got duplicated ducts here, which shows the conflict here. Undo, again I select it, then I hide it. Look at here, select hide. Let me try again. First of all, I want to select it, but how do I understand that the object is selected? Let me open properties by this way. Let's check it out. Here if I select the duct, you can see its properties. As you can see, a rectangular duct, but I hide it by using Ctrl+H. Then again I select it, and if I hide it again, the properties will disappear. Anyway, let's talk about the different types of clashes. First of all, I should say that your only way to get access to Clash Detective here it is in Home tab, Clash Detective. I open it to open the window of Clash Detective. I will talk about the details more, but right now I want you to just watch this. Well done, let me maximize the size of window. First of all, I click on Add Test. I will talk about these. You don't have to learn these right now. After that, in Select tab or panel, and I will talk about these items later. I know some of you may not understand the process, but no matter, don't worry. I will explain all of these. Here as you can see, there are types of clashes, hard. Here if I open the drop down list, we got 4 types of clashes. For example, duplicates, searches for mistakes in the models, elements that have been modeled twice, copies and so on. And clearance checks the required minimum distance between 2 items. In other words, it checks the items in which there is not enough offset between them. Clearance is called soft clash. Suppose that you have 2 objects in your project and it should be on a specific distance between these 2. So it's the clearance's job to check the required minimum distance between these 2 items. And we got 2 types of hard clashes. Hard means that, hard checks for intersections between item geometries, just like the intersections between the duct and the beam. And as you can see, we got 2 types of hard clashes, hard and hard conservative. Hard conservative finds potential clashes when geometry does not intersect. For example, when an element contained in another one. When we use hard conservative, it detects the duplicates as well. But I don't recommend you to use hard conservative, since if you want to duplicate items, you can choose duplicate type, and if you want the intersections between the geometries, you can use hard. But when you choose hard conservative as your type, it may find some unnecessary clashes that may not be important in order to make you confused. For example, it may report the doors and windows as a clash in the walls, so it is not oftenly used. So right now let's start from duplicates. All of these 4 types has got points that they need to be told. So please watch this part carefully and don't forget to take notes. And remember that if you want to make money from Navisworks, you should have been mastered in this part of Navis. You can make money by creating animations, by reviewing or making viewpoints, but learning Clash Detective and 4D that I'm gonna talk about it in next sessions. Anyway, I choose duplicates. Here in tolerance, you can specify the range of variation permitted in maintaining a specified standard when designing. For example, if we had copied item with 10 centimeters offset, by the tolerance we can specify to consider this item as a clash or not. So for example, I can specify 0. It means that if the 2 objects were exactly overlapping each other without any offset, it should be considered as a clash. I will exemplify to clarify these items. So I specify duplicate as type and 0 as tolerance. Then I specify the files for the detection. I choose the whole project. Actually, in the clash detection process, we are always being given some clashes which are not considered as actual clashes. So we need to check the reported items, the given item, so that we should remove the unnecessary ones. And the continuation, I will talk about all of them. I click on run, check this out. For example, here we got the duplicated items. For example, in Clash 1, the door is highlighted. Since we got 2 doors, then we got 2 windows, as you can see, as they are highlighted. And after that, the rectangular docked and the another docked, as you can see. So watch this. First of all, as I told you before, we got a duplicated wall as well, which is not recognized in this clash detection. At other places, for example, like here, we got 2 similar walls which got intersections of each other, which is not recognized. Or for example, here we got 2 walls that one of them is contained in another one, and this is not recognized as well. But for now, the greatest clash which is not reported here is the wall here, which is not recognized as a clash, since we got 2 copied walls, because here there is a point. Actually, when you paste the walls aligned to the same place, their connection will be different to their lateral walls, so that these 2 walls are not recognized completely or are not reported. But right now, to convey the message better, I want to show the connection between these 2 walls. I extend the wall downward. As you can see, the other one is extended to the end, but the second one is not extended, so that this clash is not recognized as a duplication. So I consider this as a weak point of Navis. Anyway, to make it more comprehensible, I trim these 2 walls by this way, as you can see. I disconnect them from the other walls by this way, as you can see. Let me show it to you in the 3D view. Watch this. So that their condition are similar to each other. I save the project by this way, and also it will be saved in Navis too, since they are linked. Then in Navis, I click on refresh to update the changes. Then wait for a second to load the changes. I reset the clash detection. Then again, I wanna run the test. Check this out. As you can see, this time the wall is reported and it is recognized. So as a result, I want to tell you that do not rely on Navis that it would surely report the duplicated ones. But note that here we have a specified 0 for the tolerance, which means that the 2 objects should be exactly overlapping each other. But if you agree in Revit, I want to return the changes by this way. I place them to their previous place and then save. Don't forget to save your project. And then we'll refresh the project in Navis. So just save your project in Revit and then refresh your Navis file. Well done. Actually, the process of loading the changes is not getting done too fast. It's just because I'm pausing the video. But don't forget that it takes some time. I reset the project, but this time I want to specify a new value for the tolerance, for example 20 centimeters. But this time, suppose that I have modified the project units, or let me just modify the linear units in project units. I set it to meters. Well done. This time I want to specify 20 centimeters. Let's check it out, and then let's check the reports. As you can see, the doors and the windows are reported, and then the ducts, both of the ducts. But what is the next one or the last one? This is added to the new detection. As you can see, this is the 2 similar walls, as I told you, but there is a distance between these 2 walls, so that when we specify duplicates for the type and then for the value of tolerance, for example we specify 20 centimeters, each of the objects which are at the 20 centimeter offset of the other objects are considered to check that whether they are similar or not. So the objects which are placed at the 20 centimeters offset and check that if they are duplicated or not. So as a result, the walls which are different in type, here as I select them, check this out, these 2 walls are different in their thicknesses, so that they are not reported as duplicate. And again, the 2 copied walls which are pasted at the same place are not reported as a clash, since their types are different. I modify the value of tolerance to 1 meter, and as you can see, it got no influence on the clash detection, since there are no copied objects in their 1 meter distance. Here in Revit, check this out. I'm gonna give you the last example for the duplicate. Then I got a question for you. Here I copy the wall, and after that paste it here, and as you can see 1 meter offset between them. Suppose that here we got 2 walls, for example. In other words, we got a 2-layer wall. So just let us check this out. I refresh the project in Navis. And as I told you before, the refreshing process takes a long time, but I pause the video to not waste the time. But as the process of refreshing is getting done, let me give you a point. Note that the material of the walls has got no rule and influence in the application. Only their physical geometry does matter, and their thicknesses actually. For example, the duplicate in brick wall and concrete wall are distinguished in the Clash Detective. But if there is a difference in their thicknesses, this would not be recognized. The physical geometries should be the same, and their type is not important in the Clash Detective. Well done, let me reset the detection. After that, I wanna choose duplicates again as type and modify the value of tolerance 1 meter and then run the test. Well done, let's check it out. For example, here as you can see, so many objects are distinguished. For example, the duplicated items, the walls, doors, ducts, and these 2 doors as you can see. Since we got a duplication here, let me show it to you in Revit. The doors which are in front of each other are reported as a clash. So as a result, this is a very important point that you should take into consideration, that if even there was no intersection or duplicate or overlapping, they would be recognized if you specify 1 meter for the tolerance. That as you can see, the specified type is duplicates and the tolerance is 1 meter. And here I got a question about duplicates type, and then we will go for other parts. As you remember, we had some duplicates in the beams too. I mean, the beams are overlapping each other. Check this out as you can see. But why didn't Navis report these? Why the duplication in the beams and their overlapping was not recognized? The point here is that when you duplicate the concrete elements would join to each other in a way that they are recognized as a single element, so that Navis would recognize them as a single element. Here let me move the concrete beam. Check this out. Here if I press escape, as you can see, they are considered a single object. The elements are joined to each other, and this is a rule and point in concrete elements, so that they would not be recognized as a clash detection in Navis. But if the duplication was in 2 different materials, for example a concrete and metal beam, is going to be recognized or reported as a clash. Well done, let's talk about clearance. So I specify clearance for type. As I told you before, clearance checks the required minimum distance between 2 items. And you specify the distance, the minimum distance in tolerance. So in clearance, the value you specify in tolerance is considered as the minimum offset that is required between 2 items. But what is the function? For example, here there should be a specific distance between the beams and the light. Because of some reason, such as the installation of the lights and having access to the lights and so on. Here I wanna select the same type of the lights. I will talk about the other details later. As you can see, I have selected all of the types in the lights by this way. After that, I'm gonna select the same type of the beams by this way, like this way, and other concrete beams. Well done. To consider them in the process of clash detection, and I will talk about this detail, that how can we specify the selections. Then I specify the minimum offset in tolerance, for example 0.5, which is, then I click on run. Check this out, there is no object reported here, since the minimum offset isn't ignored here. Here if I modify the value of tolerance 1 meter, for example, check this out for items, so it means that the required distance is ignored and is not considered. Let's check them out by this way. The highlighted lamps, however, we should change the view to observe them better, so the required offset or distance is not considered in these lamps. Here if I reset the detection, this time I want to check the ducts since they are more important. So here I'm gonna specify the objects. For example, I select the ducts rectangular ducts by selecting same type. The offset between the lamps and ducts, 0.5 for the tolerance, then run the test. Check this out, we got 10 clashes, almost all of the lamps, that the required distance is not considered, which it means that it is less than 0.5 meters. So in clearance, you specify two types of objects, and then you can specify a value in tolerance, then it checks the required minimum distance between the two items you have selected. So again, you specify two groups of items or objects here in clearance type, and then the process will be done in your specified tolerance, which is called soft clash as well. That checks the required minimum distance between the two group of items. As I exemplified, for example, we can specify a required distance between the lamps and the rectangular ducts, or the, for example, ducts and beams and stuff like that, that you can do them by clearance. And the next type is hard, which checks for intersections between item geometries, and it is the most oftenly used type, unlike hard conservative, since it reports the duplications to you, so it is not oftenly used. And find the potential clashes when geometry does not intersect. Here I'm gonna give you an example. Here let me modify the selection groups or items to apply it on the whole project by this way. I will talk about the standards and the classification here, or clash matrix, or the group of items which are considered in the clash detection process. But right now just focus on the types of the clash detection. Anyway, let's talk about hard conservative. First of all, what is the tolerance here? We talked about it in the duplication, that if you specify 0, it means that the two items should be exactly overlapping each other, and then in clearance, I told that the value you specify in tolerance is the minimum required offset. So if the distance is going to be less than the specified value, then it will be reported as a clash. And here if I specify 0.05 is the minimum value which two objects overlapping each other. For example, we got two objects that are exactly parallel and overlap each other slightly at their ends. And here if I specify 5 centimeters, the 5 centimeters overlapping is not going to be reported, since we are not going to face with problems. However, we do not specify 0 for the tolerance. 0 means that a small intersection is going to be reported as a clash, but about 5 centimeters is more serious actually. So 1 centimeter intersection between two objects is not that much important, since it is going to be fixed. So here if I specify 5 centimeters, the intersection below the 5 centimeters are not going to be considered. I run the test. Check this out, we got 72 clashes. Let's check them out. For example, we got an intersection between the column and the ceiling, which is not considered as a clash. So this is the conservative type, but the position of the column is voided and it is joined to the ceiling and there is no problem. Or for example, these two walls, as you can see, which one of them contained in the another one, it is reported as a clash. Or let me check others. As you can see, all of the columns are reported, which are not really clash. Look, they are okay, and the columns does not intersect. But conservative type finds potential clashes, even the doors and walls. So I do not recommend to use hard conservative type. But about hard, it is one of the most useful types, which checks for intersections between item geometry. It displays the actual intersections, not the potential ones. Check this out, these are the 5 centimeter clashes. For example, the pipe is passing through the wall. Check this out. Or we got the intersection between the ducts and beams, as you can see by this way. And as you can see, the intersection is between a single duct and multiple beams. Look. These are the actual intersections. These should be considered. These are not potential clashes. For example, when we got an intersection between the duct and a beam, they should be fixed. They are clashes. They cause problem. So they are reported. So to come to conclusion, and after that I'm going to start our main topic, the techniques, the points which are related to clash detection. Anyway, in the clash detection process, we rarely use hard conservative type, and we use the type hard to check for intersections between item geometry, and we usually set 3 or 5 for the value of tolerance, to not make it that much sensitive since smaller values are solvable as an intersection, so the standard values are 3 or 5. And about clearance, I should say that it checks the required minimum distance between two groups of items, and its second name is soft clash, and duplicates search for mistakes in the models, elements that have been modeled twice, copies and so on. So it is not related to the intersections and the distance. It just corrects your mistakes by searching for them and report them. So this is all you should know when you rush a clash test. But right now, let's talk about the clash detective from the beginning, or the other details that you need them to know to run a clash test. However, I showed you some of them previously. And right now I have talked about the types of clashes, so I remove one of the models. And right now we're just gonna work on this model. So let me remove the duplicates. Well done, and after preparing the model I save it by this way. And following that we'll work on this model. Very well. I refresh the project in Navis. And then I will continue the lesson to teach you everything about running a clash test, such as where to start, the items or objects we should specify them for the standards, and so on from the beginning. Well, if you do agree, I specify shaded and screen lights in order to observe the model better. So as I mentioned before, for launching your clash detection process, at first you should click on Clash Detective. Then the window of Clash Detective will be opened. You may have several clash detection processes in your Navis project. I think always more than 10 processes. For example, beams and ceilings, beams and lamps, beams and docks, docks and docks, pipes and pipes. And about these, I have prepared an Excel file that you will be given, so don't worry about it. And note that when we run a clash test, we specify the group of the elements which are going to be checked or considered in the clash detection process, because some elements are not considered in the clash detection, like walls. And when a pipe passes through the wall, it is not considered as a clash in the real project, since the wall is going to be voided. And we got the same thing with the floor, that the place of the pipes are going to be voided in under the floor, so it is not considered as a clash. And we do not consider walls and floors in the clash detection, so these standards are not necessary in the clash detection process. So as a result, some objects are not engaged in the clash detection process at all. As I mentioned before, walls and floors are not engaged in the clash detection, so that we cannot specify the whole project in the standards for checking the clashes, because we should classify the standards as I told you. For example, beams and ducts, beams and pipes, or ducts and pipes, or ducts and docks. And I will share an Excel file with you that the standards are mentioned in, so that you will be informed with the standards of the clash detection. Anyway, to run a clash test, we should at first open it. After that, I click on Add Test to run a clash test. By this way, check this out. Then the first thing to do is to specify into a group of objects that you want to check for clashes. So I'm gonna say that again, then we do not have comprehensive clash detection or a clash detection for the entire project, because we specify two group of objects as the standards of clash detection. So here I right click to rename it. For example, here one of the most crucial ones is that to check the ducts, for example. So I type duct and their relation with beams. Actually, I'm going to check the clashes between the ducts and beams, or framing, duct and framing, or structural framing. Let me modify its name. Well done. Very well. Following specifying the name, here I want to specify ducts and framings as my standards, so that I should specify or select the ducts in selection A and the structural framing in selection B. So the most important topic for running a clash test here is that to have a correct choice or selection actually. I mean the items which are going to be associated for the selections A and B should be correctly specified. So following that, I want to give you 3 ways and approaches. And if you learn these 3 ways, by the end of the session, you will be almost able to run a clash test in order to have correct selections. And in the continuation, to clarify this topic, I'm gonna create some categories here. Following that, I would explain the 3 ways for you. Then I will explain each of the ways in each of these tests. So I renamed the new test, which I have just added. So I right click, rename. For example, I name it to lighting, and since I'm going to consider the lights of the project with, for example, let me see, lighting and structural framing, for example. Actually, structural framing should be considered with all of the elements. I add one more test. And then one of the most important elements, for example, ducts and ceiling. Don't forget that you should check these intersections with other elements. That the required distance between ducts and ceilings should be considered, which is considered well. Let me check the model in Revit. Then I select one of the ducts to move it down. Since we're going to have an intersection, or I can move the pipe. I move down the pipe. Let me modify the value of middle elevation. Check this out. Well done. Right now our project has a clash that is going to be reported by Navis. And for the lighting and structural framing, actually there's no clashes. I refresh the project. Right now I have placed the pipe inside the ceiling, so I should modify the name duct and pipes, not ceilings. But our main topic, which is so time consuming, is to choose correct test criteria. I mean, when we add the tests, the select tab will automatically be displayed to enable us to set up test criteria, and we should set up them correctly. I will continue after saving and refreshing the project in Navis, since Navis and Revit should be linked to each other and be updated. Very well, so how to set up the test criteria in the selection A and B. How to associate, for example, pipes for selection A, and how to associate ducts for selection B, for example. And as I told you, we got 3 ways. So please watch this part carefully. Let me modify the name, pipes and ceiling. Let me start with the first approach, which is my favorite actually, and I normally use this way, and I recommend you to use this way. Here I click on Find Items. As you can see, the window of Find Items is opened. Here you should save selection sets at the number of your categories in your project. But what does it mean? I mean, you should collect all of these structural framing in one category and then save it as a selection set. After that, the ducts. Then save the pipes as the selection set, and so on. But how? First of all, I should specify the category. Here, if I want to choose only the ducts, we can use Find Item tool, as you can see. So what should I specify for the category? So surely ducts. But how can I find ducts? I mean, which of the categories should I select to get access to pipes? I mean ducts. As you know, the category is ducts, but where we can find it? Do you remember it? I want you to remember it absolutely in element. So first of all, I choose element. Then I open the property drop-down list category. The categories which are equal to ducts. And as you can see in the drop-down list of value, all of the categories are gathered. And we should create selection sets from all of them. However, this process is too time consuming, but if you want to save your time, you can write a script for it. For example, you can use Dynamo. But if you do not know how to work with Dynamo, for example, you can take your time and create selection sets. For example, if I want to specify the structural framings as a selection set, let me see. I open the value drop-down list. Then I choose structural framing. Then I click on Find All. Right now all of them are selected. Then I save the selection set. After that, I assign a name for my selection set. So let me rename it, then I paste its name. Structural framing, finish. Let's go for the next selection sets, which is ducts, but copy its name before finding them. Find all. Then I click on save selection. I paste the name. Right now our selection set is ready. What else we have? Exactly lighting fixtures. I copy its name, then I click on find all by this way. I save the selection set. I paste the name. Well done. What is the next? Absolutely, ceilings. I copy ceiling, then I click on save selection to save the selection set of ceilings. So before running a clash test, you should create or save selection sets from all of the categories you have in your project, and you want to consider them as your test criteria, and I believe this is the best way for running a clash test. I close the unused windows. Now check this out. The first one is ducts and framings. So I open the drop down list, then I choose sets, and also in selection B, right now I should choose ducts and structural framings. So by this way you can set up your test criteria. But before that you should prepare your categories by saving the selection sets. And after setting up your test criteria, you specify the type, the tolerance, and then you can run the test. Check this out in a very simple way. And right now the clashes and intersections are reported. So there are 4 intersections between ducts and framings. In other words, 4 instances of the structural framing elements got intersections with ducts. Let's go for lighting and structural framing. First of all, in select tab, modify the test criteria, sets in this way, in both selections. Then I choose lighting fixtures and then the structural framing. Then I specify the type and the tolerance. Let's check it out. There's no clashes as you can see. Well done. Pipes and ceilings. Again, I go through the same way. Or let me say that my way. But I want to reduce to another ways. But I do not use them since I think this is the ideal way. However, the another 2 ways has got some advantages. But in compared to the first way, I prefer to use this way. Pipe and ceilings. Actually, I haven't created the selection set of pipes. Again, in find items, elements, category, condition, ceilings. Here I should specify pipes. We have talked about all of these items in the properties. As you remember that when you select an object and then open the properties, let us have a short review. You can find the category in element. So should specify element for the category, then category as the property, then the condition, and after that the value, which is pipes here. By this way I copy the name, then I save the selection set. By this way, then I paste its name. I press enter. Check this out. In the selection set, it is saved in the selection set. Well done. Let's set up these test criteria, which are pipes and ceilings. Then I run the test. Let's check it out. We got no clashes, which it means that the intersection is less than 5 centimeters. But here we're allowed to reduce the value of tolerance because of the low thickness value of the pipes. For example, 1 centimeters. Again, nothing is reported. Why? Actually guys, I have paused the video to check for problem. Then I found out that I made a mistake in selecting the ceilings. I mean, the selection sets in lighting fixtures and ceilings are the same, because having no clashes and reports was not normal. So from this mistake we can learn a lesson that before starting running our test, we should check out our selection sets. By this way you can just select them and check if the right objects are associated to your selection sets. Since if you make a mistake, then no clashes will be reported. But we were sure that there is absolutely some clashes between pipes and ceilings. And here as you can see, ceilings is not correctly selected. So I modify my selection set, find all, ceilings, well done. Then I update my ceilings by a right click to modify the selection set. Well done. So in this condition you can update your selection set. Well done, let's go and well done, everything is okay. Let's adjust the tolerance. 5 centimeters, run clash test. And as you can see, the replaced pipe is reported. Up to this point, we have run the clash tests between clash groups of ducts and framings, lighting and framing, and pipe and ceiling. I specify them in the test criteria. However, some may want to specify a specific value for the tolerance when running a clash test for each of the clash groups. But normally, we specify 3 to 5 centimeters for the tolerance, and it is acceptable. So our first way for having correct test criteria in selection is creating or saving selection set by using find items, and I think it is the best and ideal way. But what is the second way? For example, if I want to consider ducts and framings as my clash groups, but before that let me add one more test, then I rename it D as duct and F as framing since I want to keep the last tests. So the second way here is that I specify properties for the selection. Here as you can see we got 4 modes: standard, compact, properties and sets, and we got the similar items in selection tree as you can see. So you're already familiar with them. These are the same. So you know them, and if you have forgotten them, I recommend you to watch the video again so that you can remind these items again. Here if I specify properties, then in the subcategories of the element, I choose the category as you can see. So we are looking for ducts, and then I choose ducts. Then for the other side or the selection B element, then the category, and after that the structural framing. By this way, and after specifying the type and the tolerance, I can run the test. But this way has got a positive feature in compared to other ways. Selection sets aren't being updated normally. I mean, if I revise my Revit file and add some more elements to, for example, a structural framing sets, the selection set would not be updated, and it sets up the previous set as the test criteria. But if we use this way, your test criteria is always updated, since it sets up the, for example, structural framings as the test criteria at the moment, so it doesn't need to be updated. So this is the positive feature it has, that your selected items are always updated. But if you are finished with your project and you want to start your clash detection process, this is not the recommended way, since you're at the final stage of your project and you can use find items to just save your selection sets and then run your clash test. But if you're not done with your project, you got so much to do with it, or you are at the beginning of your project and you need your categories to be updated, this is the best and recommended way, because your specified test criteria are being updated with your RVT file, and then you can run your test. So in the second way, we set up our test criteria by specifying property, and after that we specify the category in which the latest changes are applied on your elements. And although this is a good way, to use, but it is just a little bit time consuming. Anyway, but what is the third way? I specify a standard for both the test criteria. The third way is usually used for the small projects, or in other words, in the projects which you want to take a small group of elements into consideration. I mean, you are not dealing with so many objects, and to be honest, I used it while I was talking about the types of the clashes. Suppose that I want to consider the beams and the ducts, or framing and the ducts as my clash groups. So I select the beam, and then I use the select same type. So I open the drop down list, select same, then I choose same type. Actually, this way has got a negative feature, which is you may have different types of structural framings in your project. So as I told you before, this way is used for limited conditions for small projects. For instance, to run a clash test just in a single level. So by this way, only one type of your structural framing will be considered as the test criteria. Or you should select 2 types and then selecting the same types. So right now, as you can see, I have selected the desired framings, but how can I associate them to the test criteria? By clicking on use current selection, so that only the currently selected objects would be considered for the test criteria, which are assigned for selection A. I deselect the objects by this way, then I select the duct. After that, select same type. As you can see, the two ducts are selected. Then in selection B, I click on use current selection, so only these two rectangular ducts are considered. Then I run the test. Well done, did you get it? Let's have a review about our third way. As I showed you in the third way, in our scene we select the objects, or other ways of selecting elements which I told you before, for example find item or select same or selection sets or whatever you want to select your objects in your scene, and after that you can associate them to the test criteria by clicking on use current selection. Then your selected object will be attached to the selection A and B, and as you know you should do it 2 times for the 2 types of your test criteria, and then you can run your clash test. Well done, we are done with the 3 ways and approaches for running a clash test and also for setting up the test criteria. So please, if you haven't understand the process, I want you to watch the video again, because the main things that you should know and is required to know while you want to run a clash test, which is setting up your test criteria correctly. In the continuation, let's talk about these icons and check them out. And most of them are useful, and I'm gonna start with select in scene, which is next to use currently selection. But what is select in scene? Actually, it is unlike the use currently selection. I mean, when you select or click on select in scene, so it selects your specified test criteria in your scene. I mean, it's objects actually. For example, look at the ducts. For example, you want to check that whether all of the structural framing elements are selected or not. So you click on select in scene, and as you can see, all of them are selected. And as you remember, while I was describing the first way, I made a mistake. So I checked this associated object to the selection set by using this tool. I mean, at first I selected ceilings, then I clicked on select in scene, then I saw that the lighting fixtures were highlighted instead of ceilings. So by this way I was aware of my mistake. Thenceforth you can use this tool while you're specifying your test criteria, for example, for checking whether they are specified correctly or not. For example, here none of them is selected, so the test criteria is not specified. I select one of the dots, then I select the same type, then I associate it to the selection B, then I check it out by clicking on select in scene. So it means that these 2 rectangular ducts which are selected in the scene are going to be considered in the clash detection. But this tool may not be that much helpful in the big projects, since in the complicated project you may have too many objects which are covering each other. Here we select the elements to be checked. I mean, here we specify the elements which are going to be checked or which are going to be engaged in the clash detection test. For example, the first one is surfaces, which includes surface geometry in the clash test. And the clash test without surfaces does not make sense. So we should always select this, since the geometry of the objects are going to be checked. And the next one is line, which include line geometry in the clash test. You may wonder, okay, what is line? Guys, when we import a file from AutoCAD to Navis, all of the objects are recognized as a line. If I want to clarify it more, suppose that somebody has drawn the pipes in AutoCAD by using lines. Following that, you want to check the lines in your clash detection test in order to find the intersections, so you should check lines. But if you do not select line here, the intersections which are related to the lines are not going to be reported, so you can use it while you are importing a file from AutoCAD. And the next one is points, which include point geometry in the clash test. Same as line, points are exported from AutoCAD too. But note that points and lines are not transferred from Revit to Navis, but only the geometry of your objects are going to be transferred, are going to be exported to Navis, but the points and lines never. And selecting points and lines is not necessary. And about self-intersect. Self-intersect tests the selected geometry against itself for clashes. And actually this is used for the geometries or the objects which got intersections with themselves, for example like stirrups. And we do not consider the self-intersections as a clash. So these elements are not going to be checked in the clash detection test. So guys, up to this point, we have covered all of the tools which are found in the Select tab, which are frightfully crucial to be known. Anyway, let's continue the lesson. First of all, for removing your unneeded test, you can right click and then delete it by this way. In the continuation, I'm gonna talk about this icon and then the status, which is specified as old. If you make some changes in your tests which have been run previously, the status will be shown as old. For example, here I have specified 5 centimeters for the value of tolerance. Here, if I modify it and set it 4 centimeters, a warning will be displayed, which it means that these test settings have changed since this test was last run, and the results may not accurately represent the current state of the model. And if I want to update the clash test, I should click on run test again. And here if I click on run test, as you can see, the status is done. So the warning icon means that the model or test settings have changed since this test was last run, and results may not accurately represent the current state of the model. And here we got another option, which is reset, that you can get access to reset by right click as well. Here if I reset the test, the adjusted settings will be reset and also the result, but as you can see, the test criteria are remained. So as you can see, the items in selection A and B are kept and the result is removed, and you can adjust your settings again. So reset is used when you want to adjust your settings again, meanwhile keeping your test criteria in selection A and B. In the continuation, let's talk about Rules tab. As you can see in Rules tab, here as you can see, using Ignore Clash rules reduce the number of clash results by ignoring certain combinations of clashing items, and the Clash Detective tool includes both the default clash rules and clash rule templates that can be used to create custom clash rules. As you can see, the first one is items in same layer. Any items found clashing that are in the same layer are not reported in the results. You know, this is useful if, for example, you want to ignore clashes on the same level from Revit file, but note that layer means level in Navis. But we do not check this option to ignore this option, items. And the next one, items in same group, block or cell, ignores any items found clashing that are in the same group or inserted block. And like the last one, we do not check these. Or items in the same file, ignores any items found clashing that are in the same file, either externally referenced or appended. For example, if your models contain multiple Revit files, this option enables you to only search for clashes between different files. So ignore searching clashes, for example, the items which are both in the architectural file, and this is rarely used actually. And then items with coincident snap points. If I select this option, then any items found clashing that have snap points that coincide are not reported in the results. And you can add more rules from your rule templates. For example, same property value, so it ignores them. To me, none of them is functional and useful, but you may want to use them in our, specific projects. All in all, it was my responsibility to explain these rules, but they are not that much functional. I have explained select before, and the results, as you can see, displays the results and the findings of the clash detection test, so that it informs us by the number of the clashes, the level, status and others. But before talking about report, which is our last topic, I'm gonna talk about display settings, which shows or hides the display settings panel. Since I consider this as an important topic here in the clash detection, after covering the setting, I will talk about report and other topics. As you know, the findings are displayed in results, but we can modify the displayment of the results in display settings. So let's talk about the displayment of the results. Here, as you can see in highlighting, the first item is specified to be shown in red, and the second one is specified to be shown in green. Item 1 is selection A and item 2 is selection B. So the item 1 or the first item is shown in red, and the second items or the selection B is shown in green. And if you disable the color, then the actual colors of the objects will be shown, as you can see. But here, if I enable one of them, for example the first item, only the first one will be displayed in red, and I can click on item 2 to display it in green. So by clicking on the items 1 and 2, you can control the color of their highlighting in your scene. You can either specify red and green or use item colors. However, you got another choice, which is use status color. If I specify a status color, the status color of each of the clash tests would be assigned to the objects. Actually, this would be sometimes functional, but I will talk about it later. And about the status, for example, red stands at new, or orange means active, but till now I haven't talked about the types of status, so I will talk about it later. But all I want to say that is you can associate the color of the status to your objects, so you can either use the item colors or the status color, that you can control them by selecting and deselecting them. And here, if I select highlight all clashes, after that all of the existing clashes which are found in the current clash detection test will be highlighted. For example, right now, as we got 4 clashes, all of them are highlighted in the scene. And these 4 clashes are only related to the first clash detection test. Thenceforth, you can analyze and observe the entire clash in your test all together. And actually, at the final session, I'm gonna review all of these topics, especially the clash detection test and the colors. If we use highlight all clashes, it helps us to distinguish the density of the clashes in the whole project, or to recognize the places in the project in which more clashes are found. And about isolation, right now, as you can see in the scene, all of the objects are dimmed except the objects which got clashes or intersections. Since I have checked dim other items, and it's isolate the clashing items by dimming the other items, that you can choose to dim them or hide them. And if you do not dim the other object, it would be hard to observe the clashes. So I think dim other is the ideal choice here. But here below dim other, we got another option, which is transparent dimming. This would transparent the dimmed objects too, in a way that, as you can see, we are seeing some lines instead of the objects. But here, if I uncheck transparent dimming, check this out, this is the result. So this would make trouble while observing the objects which got intersections. So all in all, dim other and checking transparent dimming is the best choice here in isolation. I mean, these two options complete each other. And if I check hide other or select it, it hides all except the clashes. And if you select the clashes, only the clashes are shown and the other items are hidden. It is not useful because you cannot recognize the location of your clash. However, it has its own specific functions. For example, sometimes you may want to select the objects which got intersections. You may have problem to find them, so you can hide other objects. Then you can get access to the clashes. Then you can select them and then check the properties since the others are hidden. And after that, you can disable hide other and then choose dim other. But don't forget to select transparent dimming since it completes the dim other option. But about auto reveal, actually this would hide the behind objects, but it has not a main effect while the other objects are transparent, and it is more visible in the big projects. Here, as you can see, as I check and uncheck auto reveal, it has no effect on the scene. But I will give you some examples later to show you how auto reveal works. And then you will see that it hides the objects which are placed at the behind of the model or behind of the clashes, so that you can observe the clashes better. And I recommend you to check auto reveal, although it has not a high influence on the scene, but it can help you to display the clashes better. And let's talk about viewpoint. As you can see, auto update will automatically choose an appropriate viewpoint or load or save one and save any subsequent changes. Let me uncheck highlight all clashes and then again choose the clashes. I deselect the objects. Look, as I select the clashes, the viewpoint will automatically change and focus on the associated object. Another option here is animate transitions. Here if I select the checkbox, what do you think about it? Let me select one example, clash tree, check this out. Then it focuses on the clashes in the manner of animation, as you can see. But if I deselect animate transition, check this out, it jumps between the clashes. But if I check it again, after that we have a smooth transition between the clashes. Let me try again, check this out. It helps you to distinguish the position of the clash better, since as it rotates, you can observe other elevations. And the drop down list, we got 3 choices. The first is auto update, the next is auto load, and the third is manual. Auto update and auto load are the same, and actually they are irrelevant to our today's topic. But what does manual do? For example, when you choose or select clash 1 or clash 2, as you can see, the viewpoint is fixed. The viewpoint is not changing. But if you want to focus on each of the clashes and the objects, you should click on focus on clash in a manual manner. Check this out. As you can see, the viewpoint is focused on clashes. You just need to click on the clash and then focus on clash. While if you choose auto update, the viewpoint would automatically focuses on the clash. As you can see, the animate transition is enabled too. I recommend you to choose manual for viewpoint, especially in small projects, since our field of view covers the whole project, so it is not necessary to focus on the clashes. Zooming in and zooming out on the clashes seems like just wasting time. And the next one is show simulation. It refers to 4D simulation actually, but I will talk about it later. And here it is not functional. It's just used for the presentations, but has got no function in the clash detection. Unlike viewing context, which is so useful. Suppose that you're observing a clash in your scene, and the viewpoint is highly focused on the clash in the manner that you can distinguish the place of the clash. So you click on view, the viewpoint will be zoomed out. After that, it will focus again. Then in the drop down list, you got 3 choices, all, file and home. If you choose all, the zoom extent would be applied on the entire project, and if you choose file, the zoom extent would be applied only on the specific file, for example architectural. And as you can see, after the zoom extent, it instantly focuses on the object again. And about home, you got access to the home by right click, which it means that you can set a viewpoint and consider it as your home by right click. Check this out, set current view as home. Before that, let me adjust the viewpoint to consider it as the home. Then I set current view as home by this way, and after that, if I choose all for view in context, this would happen. Check this out. Then if I click on view, check this out, as you can see, it preserves the previous view. But here if I specify as view in context and then click on view, it jumps to the view home. Look, no matter what the current view is, it changes the view to view home. Then it returns again. Check this out as I click on view, and right now as you can see, it is remained in the home view. So view in context is used to have a view or to have an observation to a specific viewpoint just for a moment, or having a glance at a specific viewpoint and then returning back. For example, I focus on one of the clashes. I set all for view in context. Check this out, this is the animate transition. I adjust the viewpoint, for example, in this way. Then I set the view in context home, I click on view. Then we can have a glance at the view home, and then it returns to its previous place. That you can use it while observing your clashes and your geometries while you want to have a glance at a specific object. Guys, we have covered the display setting of the clash detection used for when we have done our clash detection tests and we are checking our results and findings, and then we want to control the displayment of the results and to display them in the manner we want. That, as I showed you in highlighting, isolation, viewpoints, and the viewing context. We can choose how to show them, but following that, let's talk about the topics, the items in results. For example, grouping and ungrouping the clashes. For example, if I want to group these two clashes, it is used for when you want to classify or categorize your clashes. Or for example, classify all of the clashes which are related to the ducts. Let me uncheck animate transition. Let me check these three clashes. I want to group them. The first one and the third one. They both are related to one duct, to a single duct. So I select them, right click, and then I click on group. Then I can assign a new name for my group. For example, framing 1 or whatever you want. Actually ducts, I'm sorry. I assign duct 1. And the rest of them are going to be assigned for the framings. So I make a group, then I name the group as framing or duct 2. As an example, you can name them whatever you want. Suppose that after a while I don't want these clashes to be grouped anymore. So I right click and I click on explode group. Then they will be ungrouped. However, we can click on new group to create a new empty clash group. Let me explode this group. If I select one of the clashes, then I click on group selected clashes. It combines the selected clashes into a group. You can use this tool instead of right click and click on group. And you may want to remove a specific clash from your group. You can click on remove from group. Or if you want to add a clash to the group, you can click and drag it and drop it into the group. And for removing, you can drag it and drop it outside the group. So you got 3 ways for grouping and ungrouping your clashes: explode group, remove from group, and group selected clashes, and new group, that it creates an empty clash group. Then you can use click and drag to add the clashes to your new group. Check this out in this way. It is used for categorizing your clashes. When you got so many clashes, I explode the group. I keep one of the groups, but I remove the rest of them. So 2 of the clashes are grouped and the rest of them are ungrouped. So all of these were about grouping and ungrouping your clashes. Previously, I was talking about comments, that you can put comments or add comments on clash detection as well. For example, if I want to add a comment to my clash 2, I can right click by this way and then I click on add comment. After that, you can describe your explanations to associate it to clash 2. Then I mentioned that the size of the structural framing should be revised because of the clash detection reports. So later you can modify the size of the structural framing and then reduce the height of the framing. Well done. Okay, let me arrange the size of these panels. Here, as you can see, we got a comment icon, which means that there is an associated comment to clash 2. Then, as I told you before, you can add comments as much as you want. And then here in the continuation, I mentioned that the plan should be considered. Okay, you see. But right now, how can I display the added comments? I just need to select the clash detection test reports. Then if I select them, as you can see, the comments are displayed and the red icon or color shows that this clash is referring to item number 1. However, the red color shows the status of the clash 2, which is new, and I will talk about the status later. I open find comments. As you can see, I have checked clash detective as well. Here, if I click on find, 2 comments which I have added to the clash detective reports are displayed here. So by right click, you can add your comments, and then by clicking on the clash reports, you can display them. The next topic which I'm gonna talk about is the status, and I will consider it on the projects as well and its influences on your projects. The first one is new. It means that a clash found for the first time in the current run of the test. Active means that a clash found in a previous run of the test and not resolved. Reviewed means that a clash previously found and marked by someone as reviewed. It is used for some time that you have reviewed the clash and you have marked it since that was not necessary to be revised. Or in other words, when you review a clash, you ignore it Approved means that a clash previously found and approved by you. In other words, you are aware of the existing clash and you have approved the clash. So after accepting the clash, you want to revise the object to remove the clash. And about resolved means that a clash found in a previous run of the test and not in the current run of the test. The issue is therefore assumed as be resolved by changes to the design file and automatically updated to this status. So new means that a new clash test. Active shows a clash which is not resolved. Reviewed is for having seen the clash and ignore it. Approved is used for when you approve the clash detection report, so that you can decide to resolve it or ignore it. But you have accepted that the clash does exist, so you can revise it or not. And resolved is for the resolved clash test, or assumed to be resolved by changes to the design file. And I will talk about their functions in your project. Here there is a point. If you specify the status of, for example, if you change the status of one of the clashes manually to resolved, for example, its color would change to yellow, as you can see. But if you change the status of the group to resolved, for example, it would apply on all of the member of the groups. As you can see, the two grouped clashes are changed to yellow. But if you modify the value of a status while the presentation, for example, among your clients, I change this to new. Suppose that you're analyzing the clashes one by one, and after presenting the clashes to your employer, after that your employer ignores one of the clashes, for example clash number 2, so you set it to review. Following that, he says that the clash number 4 is resolved, so you change it to resolved manually. But about the modification of the status of the clash reports, I will talk about it later. Anyway, following that, as you can see, level shows the level of each of the clashes in which they positioned, and as you can see, all of them are on level 1. Following that, we got the grid intersection in which the clashes and intersections are positioned. Then in found, you got the date in which the clash test has been run. Here, if you approve a clash test or report, suppose that in the presentation session your employer may approve some of the clashes, so we don't have to care about it anymore. So first of all, I change the status manually to approved. Then in approved by, my name will be mentioned, as you can see. So just in case, if somebody else opens this project, he would be aware of the approver of this clash. So I would be responsible about approving this clash, since my name is tagged here. And it shows that I got the permission to approve this clash. And the date is mentioned as well. So as soon as you change the status of a clash manually, your name will be mentioned here below approved by, so that it should be responsible for it. And following that in description, it shows the type of the clash detection test. Duplicates, hard conservative, clearance, that here is hard, and also the distance, the value or the distance of intersection of these two items or objects are mentioned here. And for example, it has influence on reviewing or approving the clash test report. Suppose that you have a specified 5 centimeters for your tolerance while the distance is 6 centimeters. So you may want to approve this clash report and ignore to revise it. Then you can specify approved. So after approving the clash report, you can add a comment by right click that it does not to be revised. Or for example, you can mention the required minimum distance between the two objects, which is told by your employer. In other words, this comment justifies the approving of the clash, or an answer to the question why this clash was approved. So you can read the comment and the explanations about approving the clash, because the reason is mentioned in the comment. Actually, we can assign a clash or a clash group to a person or trait, and the difference between assigning and adding comment is that you specify a name of the person or a trait which is special that you want to assign the clash to. Suppose that I select one of the clashes that the structural file should be revised. So I right click, then I click on assign. Then I assign this clash to a specific person who is in charge of the structural file of the project. After specifying the name, then I leave some explanations for him or her, that for example the size of the structural framing should be already used or should be revised or whatever. We can enter any notes as required, and this can be viewed in the commands window. And as I told you, the difference with command is that assigned is associated to a specific person or trait. And for viewing the notes of the assigned, as I told you, we can view them in commands window. So when we share this file to who is responsible for the structural issues of the project, he would opens this file, for example, then he checks the notes which are assigned to SDR since they are relevant to him or her. But how should he or she get access to the notes of assignment? So as I told you before, the notes in the assignment can be viewed in the commands window. So I open it, check this out, assigned to SDR, and we can read the note here. So guys, we have learned a new point. Both commands and assign can be viewed in the view command window. But note that before viewing the commands, you should select your clash, the clash report actually. But if you do not select your clash report, the commands won't be viewed. So before viewing the commands and the assignments, select the clash report. Well done, up to this point we have covered assigned to, distance, description, approved by, and other. And they are very functional, especially distance, especially assigned to, that you can use it when your presentation come to an end, and then share the file with others who are in charge of, for example, architectural or the structural issues of the file, so that they can revise the project based on the clash reports. Following that, I'm going to talk about a status more as the final topic of this session to elaborate the status, and then we will talk about the reports and some other options of Clash Detective. And after that, I'm gonna open a new project and test the points and techniques that we have learned in this session. And as I told you before, I have prepared an Excel file for you, and you will be given that file. And actually in the file, some categories of the elements are gathered that are going to be considered for the clash detection test criteria, that we will review all of these details in an actual project. But let's talk about the status more before that. I reset the tests, or the results actually. Watch this part carefully since it is important, since you're gonna learn the concept of these colors and what are they used for. Well done. Here I choose ducts and framing, for example, at first, and the intersections between these two elements. I open Select tab, where we define the items that we want to test. I'm gonna test duct against structural framing during the clash test, 5 cm tolerance, and then run the test. Let's check it out. 4 clashes are found. All of them are new. In other words, they are newly found. After that, we want to revise the project based on the found clashes or intersections. For instance, I want to revise these problems to remove the clash. So I open my Revit file. Then I modify the type of my concrete rectangular beam, for example, in this way. Then we will have no clash more. I save my file. Then I go back to Navis. Then I should refresh my Navis file to update the project in Navis 2. Following that, you will understand the concept of each of the colors and their status. But right now, just wait for a sec, since the project is being updated. Very well. Here again, I choose Select tab to run the test again. The test is going to be done based on the items or the criteria which was set up previously. But before that, I got a question for you. Please think about it and then answer. I would appreciate it. The first question is, shall we have no clashes except these 4 clashes which have been found before? As you know, we had some changes on the file or the project, but do these changes influence on the clash detection test? Absolutely no. So here, if I click on run test, what would happen? How many new clashes we will have? I want you to think about it and then guess the answer before clicking on run the test. I want you to get engaged to the topic. How many new clashes will we have? Excellent. 0. Why? Since the changes which have been applied on the project on the RVT file has not caused any new clashes to be reported in this clash test, so we will have no clashes. Could you say how many active clashes will we have offhand? Excellent. Those who answered 3 were right. You have learned the topic by heart. Active means that among the 4 clashes, only 1 of them is resolved and the 3 of them is not resolved yet. And they are still considered as the clashes. They are not resolved yet. But did we review something by modifying the status manually? Absolutely not. Or did we approve something? No. But do we have anything resolved? Or is there any clash which is resolved? Yes, of course. 1 of them is resolved. So among the 4 new clashes in this test, 3 of them are converted to active and the another one is resolved because we have revised the project file in RVT. Check it out. 4 clashes are reported here. None of them are new. 3 of them are active and 1 of them is resolved. And as they are mentioned in their colors in the reports, I open the Revit file by this way, and after that, let me see. For example, I want to revise other clashes. I modify its type. Following that, I create another clash by making some intersections, or check this out, I move it. Well done. And then I'm gonna test it in Navis. So I save the file in Revit, then I wanna refresh it in Navis. So till now I have resolved 1 of my clashes and have added 1 more clash. First of all, I refresh. Wait for a second, please. It may take some time, so please wait for a moment, but before that I want you to guess the answer of the number of the clashes: new, active, reviewed, approved, resolved. So I want all of you to answer. And I know you have guessed correctly. Right now, here if I click on run test, shall we have new clashes? Do you think new clashes are going to be found? Yes, of course. But how many? Absolutely 1. What about the active clashes? How many active clashes shall we have? Correctly, 2 active clashes. Among the 4 clashes, 2 of them are resolved, but 2 of them are left. So 3 minus 1 is 2, since 1 of them was resolved, but 2 of them are not. But a new clash has been added to our test report, in addition to 2 resolved clashes. I run, check this out. Why we don't have new clashes? What do you think? Does anybody know the answer? Who knows why we don't have a new clash here? What? Correctly, because of the selection sets. Because the new type of beam or the structural framing is not recognized in the selection set. As I told you before, if you are transferring between Navis and Revit, I don't recommend you to use the selection sets because they won't be updated. So the best choice here is to use properties. So right now all of the changes are updated here, and it's great that in the project we can check these issues, explain them, since you may face with them in your project. So again, I set up the items which are going to be considered as the test criteria, ducts and structural framing. And as I told you before, you can use these selection sets as your items that you want to set up for your test criteria. But at the final part of your project, I run the test, check it out. We got 1 new clash, which I have just made, 2 active clashes from our previous or first test, and 2 of them are resolved. Well done. So till now we understood that while we are transferring between Navis and Revit oftenly and then running the test, the changes are going to influence on the status of the clashes. Following that, let's talk about reviewed and approved. So for instance, I changed the status of 1 of the clashes manually to reviewed, for example, since it is already reported to the structural manager. So we got nothing to do with it. I specified as reviewed. I'm sorry, I made a mistake. That was a resolved one. I want to change 1 of the active ones. I change it to reviewed manually to, for example, ignore it. Following that, I approve clash number 3, for example, manually by this way. So as a result, we got 1 new clash, 1 approved and 2 resolved. The approved one is accepted, the reviewed one is ignored. All in all, they are going to be fixed. I know, sometime. And 2 of them are already resolved. Okay. After that, I run the test again. Okay, what do you expect about the results? Here, as you can see, reviewed and approved are still remained as reviewed and approved. and also resolved or remained as resolved. But why the new one is changed to active? We did nothing to the clash number 5, but it has automatically changed to active. So the point here is that we did nothing to the new clash. So when we run the test again, Navis supposes that we have revised our Revit file, and after refreshing our Navis file, we had run the test again. So it's alerting us that the previous clash, the new clash, is still there. It is not resolved yet. But it is not a new clash, it is just the previous clash, which is not resolved yet. So it is considered as an active clash. So if you do not resolve your new clashes, they will automatically change to active clashes. But my next question is, why the resolved clashes are still there? Why they are not disappeared? I mean, when a clash is resolved, what is the necessity to be displayed here? Here, if you want to hide the resolved clashes in your clash reports or clash detection test report, you should click on Compact All. If you click on Compact All, it purges the extra clashes which are resolved or which are not necessary to be displayed in your reports or results. So as a result, here we got 3 clashes which should be taken into consideration. One of them is active and the another one is reviewed and the another one is approved. Thenceforth, when we revise our Revit file to resolve the changes and update it, and then after getting back to Navis and refreshing the file and clicking around the test, you may have some resolved clashes. So if you want to hide them, you should click on Compact All. But the others are still remain because they are not resolved yet. But in this test report, it informs us the clash number 3 is approved, the clash number 2 is reviewed, and the clash number 5 is still active. So that we should go back to Revit file and revise them. And if we revise them and then again rerun the test, we can hide them if they were resolved. So up to this point, we have learned the relation between Navis and Revit and the status of the clashes and their colors and their concepts which are associated to the clashes, and I will clarify these lessons and topics more in the next session, so don't worry. I rerun the test, then I reset the test by this way. Since here a small point is left, and I am obliged to say it, which is the arrangement of the clashes, or just set them in order. But before that, let me run a test, as a sample, in which we got a high number of clashes in the reports or results, and then I want to elaborate it. And note that it is not normal to set up the same files against each other to the test criteria. And hot conservative, run the test. So following that, I'm gonna arrange these 46 clashes. So don't forget that it's just an example. Here if I click on name, then it will arrange the clashes alphabetically. But note that here we can rename the clashes by a right click. Check this out. I mean, if you got enough time, we can assign specific names for your clashes so that you won't mix up them. And then you can arrange them based on their names, or even you can arrange them based on the added comments or based on the status that you want to approve all of these clashes. So I select them, then I specify approved as the status. Following that, I specify some of them as reviewed by this way, reviewed. Then here if I click on a status, then it will arrange the clashes based on their status. But here if you click one time, it starts the arrangement from new status. But if you click one more time, the arrangement will be start from the approved ones. And as you can see, the approved clashes are arranged at the top of the list. Here we got an option named sort by proximity. Here if I click on this, then the clashes will be arranged based on your distance or the distance of camera to the clashes in the scene. In other words, it sorts clash results by their proximity to the selected clash, and the clash groups are sorted by the group member that is closest to the selected clash. Check this out. If I modify the viewpoint and then I sort them by proximity, the arrangement will be changed too. For example, the first one is 41, clash number 41. I sort it again. Right now the first one is clash number 12. So the clashes are sorted by the group member that is the closest to the selected clash. However, you can use quick filter, for example based on a status, for example review, since we have right clicked on a review status clash. But if I want to filter the approved one, I right click on the approved one, then I quickly filter them by a status approved. Then you can clear the quick filter. All of the features of this clash are displayed here, for example the assigned, level, status, that you can use this to filter them. So as I showed you, you can filter them based on their status or level. So guys, I have told you the points and the techniques which are related to status and the arrangement, but after all, I got a question for you. So let's see who knows the answer. But before that, let me reset my clash test. By this way, I want to ask the question related to this test, duct and framing. Here as you can see, we got 3 clashes which are new. I mean they are newly found. Anyway, the first question, as a warm-up question, since I think you already knew the answer, here if I again click on run test, what will happen to the new clashes? Excellent, they will change to active clashes, since no changes have been made and they are not resolved yet. Well done, but what about this question? If I change the status of an active clash to resolved, but manually, I mean a process should be done if we want an active clash to be resolved, which is revising the Revit file. But if I change the status of my active clash manually to resolved without revising my Revit file, in other words, I have enforced this clash, the active clash, to be resolved, while nothing has changed. Right now, if I click on run test, what is your expectation about the status of this clash? Actually, I'm really curious about the number of those who know the answer. So guys, if I click on run test, what is your expectation about the status of the resolved clash? I want you to think about it deeply. Guys, let me introduce the options on the table. Does it convert to active? Or does it convert to new? Or it does remain resolved? You got 3 options to choose. What is the correct answer? New, active, resolved. What is your expectation? Just focus on the process and the action. That a problem is not basically resolved, but I have changed the status manually to resolved while it is not revised. I run the test, check this out. Excellent, we got a new clash. So to come to conclusion, if we change the status of an active clash manually, it would automatically changes to a new clash. As I told you before, each time you click on run test, Navis supposes that you have revised your Revit file, and after that you have refreshed your file, so Navis has found a new clash. In other words, the resolved clash was ignored, but after that a new clash is found, which is the previous one that wasn't truly resolved. And this was the point that I think you'd better to know. And if you wanted to remove your clash tests, by right clicking on delete, you can removing them from your list, or you can reset them, compact them, rename them. As I told you before, compact all hides all of the resolved clashes, but you can use right click to compact a single clash report, or in other words, by this way you can compact and delete the clash tests individually by right click and compact, and if you click on run, it is same as run test, that you have access to it in select tab. So these two function as the same. So these were the options on the items you got in right click, and I have talked about the warning icon before, but to elaborate it again, let me reset the test. After that, I adjust the value of tolerance. Suppose that, let me see. For instance, I choose test 1, then I reset it. I want to explain something here. For example, I specify 30 centimeters for the tolerance. It is not normal actually, then I run the test. 21 clashes are found. After that, I modify the value of tolerance which was specified before. For instance, not 0.5. Not 0.05. Here I got a question. What shall happen if I modify the value of tolerance? Absolutely, the warning icon will appear, which means that we have changed these settings. After that, if I run the test again, more clashes may be found later. Am I right? So what will happen to the new clashes? If I run the test again, what will happen to the 21 new clashes? Check this out. I click on run test. As you can see, the 21 new clashes has been converted to active. It means that they exist based on the previous settings we adjusted. Then the new clashes are related to our new settings, which is the new value of the tolerance, which is 5 centimeters. Following that, I'm gonna modify it again and set 0, for example. Here even we can arrange your clashes. For example, if I want to classify the active clashes, I select one of them from the list, then I filter them by status. By this manner, we can calculate the new clashes that are being found in each test. Since here if I click on run test, the new and active clashes will be mixed to each other. So before that, I use quick filter by status, then I select all of the active clashes. As you can see, all of the active clashes are gathered here. Then I select them and set them to reviewed. Right now I have marked them to reviewed, since next time if I click on run test, the new clashes are going to be converted to active. So the reviewed marked clashes refers to the 30 centimeters value of tolerance, while the 13 new clashes refer to 5 centimeters tolerance. If I run the test with 0 tolerance, I cancel the warning, it is not important. As you can see, the 13 new clashes has been marked active right now, and this time we got 163 new clashes. You can separate your founding in this manner creatively. For example, you can mark them as reviewed. So by doing this, I can be aware of the number of the clashes at each different values of tolerance, which I have specified for these 3 tests. However, you can make some copy from the tests and then associate each of the values of tolerance to each of them, so that you can check the number of the clashes. Following that, I'm gonna talk about the bottom of the window of Clash Detective, which is items. Right here, let me open it. By this way, as you can see, let me maximize the window. You can open it by just clicking on item. By this way, right here. Anyway, right there below the display settings, we got some options. First of all, it compacts the selection tree. As you can see in the selection tab, we got so many items here. While if I show items in results tab, only the objects which are engaged in the clash test are shown here. Here, as you can see, rectangular duct and concrete rectangular beam are set up to the test, so they are displayed in the items instead of the whole entire items in the project. And you can control their colors as well as we could in display settings. But here I'm gonna tell you why should we use items, which is found in results. Because items wills us with switchback bottom, and as you can see, we can switch back to the design application for the selected item. Suppose that you could not find it is used for when you could not to find a specific object or clash which is found in the results of your clash test. So at this situation, you can use switchback by opening the item, then clicking on switchback. And as I showed you before, it will be selected in your Revit file. But before that, you should enable it in your Revit. So I open Revit again, then in Add-ins tab, I open External Tools drop-down list, then I enable Switchback to connect Navis and Revit to each other. Then if I click on Switchback, item 1, which is found as a clash in Navis, would be selected in Revit. Check this out. And this is great, so that you can revise your element without looking for it. So the big advantage, or let me say the big asset, which you are given here is Switchback, that you can use it while you want to revise your element, or while you can't find an element which is marked as a clash in Navis. Items also enables you to select these items in the scene. Check this out. Suppose that after running your clash test, you may want to check the properties of your elements, so you can use this tool to select the specify elements or the found clashes in the scene without hiding other elements. So you can use select in the scene, and don't forget that these are the most crucial points and techniques in this part, so don't forget to take notes. And these are highly useful, especially in the complex projects, and these are really practical that can help you in your several projects, and following that, saving your time. So we have dealt with the items, which is found below display setting, and its 2 practical tools, which were switchback and select in scene, that you should keep them in your minds.